had a student ask a few questions about 10.3, 10.4, and I wanted to talk about this one. We are trying to conclude whether obesity affects relationship status. And so I have 3 different relationship statuses, and obese or not. So I want to, remember when I do these tests of independence, my null hypothesis is that they are independent or not associated. And my alternative is they are not independent or they are associated. And that's this choice right here. I want to make sure that the smallest expected count I report it. Oh, so I need to figure out my expected counts. So I'm going to open this in StatCrunch. And I'm going to make an observed and an expected column. I'm going to put observed first, and that's where I'm going to put all my values. So I've got dating obese, dating not obese, cohabitating obese, cohabitating not obese, married obese, married not obese. And then I need to find my expected value. So the first thing I'm going to do is find out if none of these affected it, what percentage of the population would be obese. And so I'm going to add all these up to get the total. Oops, I needed to do calculator. So 80 plus 101 plus 154 plus 356 plus 329 plus 278. Oh, I missed it. I have 39 instead of 329. So I need 290 more. Plus 290 gives me my total number of people. Did they tell me that in the problem? No, I was just going to check. And then I need the percent that would be obese. So let me write down 1298 as my total. And then how many were obese would be 80 plus 101 plus 154 is 335. And so the percent that would normally be obese in a population if relationship status did not matter would be about 25.81%. Then what I'm going to do is find out of the dating, I would expect 25.81 to be obese. So if there was no effect at all, I would expect the same from cohabitating and married. And so I need to find these totals right here. So this total is going to be 436. This total is going to be 430. And this total is going to be 432. Let me make sure. I want to make sure I got those right. So 80 plus 356 is 436. And I would expect 25.81% of those. So times 0.2581. So my expected value would be 112.53. I'm going to do my high school graduation rates and preschool problem the exact same way. Then of these 430, if there was no effect at all, I would expect 25.81% of this 430 to be obese. Oops. 2581. And that would be 110.983. Oh, did I put that? I put that by the wrong number. That should go by the 101. Need to make sure I keep my correct spots available. For this 356, I could just take the 112.53 from the 436 to get the leftovers. So I'm going to take 436 minus 112.53. And I get 323.47. All right, so those two, this 80 and 56 and this 112 and 323 should add up to the 436 number. So now I'm at the 329. That would be the 430 minus the 110. 430. Oops, clear, clear, clear. 430 minus 110.983, which is 319.017. All right, and again, if there was no relationship, no association, I would expect 25.81% of this 432 to be obese. And I get 111.4992. And so I'm going to take 432 minus 111.4992. And I get 320.5008. So finding my expected values can be tedious, but basically you're just adding these row totals, finding the percent of the total, and then making those happen to the total columns. Now that I've got that, I can go to Stat, Goodness of Fit, chi-square test. I've got my observed column, I've got my expected column, and I'm able to compute my chi-square test statistic as 35.722. Oh, that's not what they ask. They say the smallest expected count is, what is my smallest expected count? It looks like 110.983. 110.98 rounded to 2 decimal points, which is definitely more than 5. My level of significance is 0.05. They tell me that in the problem. My chi-square value was 35.72. My p-value was 0. That's really small, so I'm going to reject H0. If I reject H0, I'm rejecting the fact that they are independent. So there is evidence that they are associated. Can we conclude that these are causal? This is an observational study. Let's see, research subjects were followed from adolescent to adulthood, and all the people were categorized in terms of whether they are obese. So I know it's no, and let's see if we're able to use this as establishing causality. We're not able to because we just observed. We didn't force these people or tell them you're dating, you're married, you're cohabitating. Find the percentages of obese people in the 3 relationship statuses. So now they want me to go and find the percent of obese dating people. So that'd be 80 divided by 436. So 18.3% dating are obese. 101 out of 430. This is going to be a long video. 23.5%. So it does look like there's a difference. And then of married, it's 154 out of 432. 35.6%. The relationship status with the greatest percentage is married, followed by cohabitating. Probably not that surprising. Hope that helps.